Okay guys, so this is the third class that I'm recording and I'm going to put on the YouTube. Please check your emails that I'm sending in group by Blackboard and providing the YouTube link, because it's going to be very difficult for me that every day I reply to your emails one by one, that where's the link. Please check your emails in the group. Okay, now let's go, and we're continuing the course, and Matlab notes. So, and we were here, that's right. Yeah, so I'm gonna make it a little bigger. So this was practice that I asked you that you do it, remember? So I'm gonna just make it a little, I'm gonna do it with you to make sure that you have done it correctly. And here we go. And this is our Matlab. Okay, so this is practice 4. Add the following vectors. I told you that you have to write A is equal to, as it is, 1, 4, 5, and 6. I'm putting semicolon because I don't want to see it again. And the B is 0, 1, 0, and 0. That's right. Or you can write this like this, guys. Look at 1, 4, 4, 5, and 6. Okay. See, this is going to give you the same result, guys. It's going to be a row vector, that's right? So it doesn't matter. So now I'm going to say C is equal to A plus B. It's capital A plus B. So the result is part A. I mean this. Now I'm modifying it A as minus 1, 4, 55, minus 6, right? And the B, upper arrow, gives you B. Here we go. It is again the same, 1, 0, 0. That's right. So again, C is A plus B. Another confirmation. And now I'm asking you that add 3 vectors together. That's right. So your A is the same for part B, for part 2, and B is the same as part 2, but sorry, part 2 was a column, so I forgot it, but no problem. So I'm going to fix it here. So this is the column vector of that. That's right. So by putting this transpose, that's how we do it. See here, it's gonna be a column. That's right. And the C now is 1, 4, 5, 6, 2, 9, and I'm gonna make it again as a column. That's right. So if I say D is equal to A plus B plus C, what do you expect to see? Yeah, why? Because the dimension of the C is a column of 1, 2, 3, 4, 5, 6. This is column of 4, so you cannot add them. See, as I taught you in the previous class, it's enough that you say lengths of C. Oh, it's a typo. Length of C, that is 6, and the length of the B, as we defined, is 4. We cannot add 2 columns that one of them has 6 elements and the other has 4 elements. This is a mistake. So what we're gonna do, we're gonna say A is so I'm gonna change only the C. I'm gonna say this. This is now it's 4 elements. So now if I say D is A plus B plus C, you're gonna have a matrix. That's right, because you have 4 by 4, because it has 4 columns and 4 rows after modifying the C. So it's gonna be 4 by 4 matrix, as I taught in the previous class, right? So the other way of showing B transpose in Matlab. So how? Let me make it a little. So I'm using this command. That's right. So how? Let me show you. As I told you, for a row, you can write a row like this. That's right. This is row. And I taught you today you can write like this. It's gonna give you another row. So you see that these are the same. This with this is the same. Now if I generate a column like as -1, 5, 3, and 4, okay, you can put this sign here to give you transpose. See that? Now you can do this. Semicolon, semicolon, and semicolon. The same numbers gives you a column. So this is up to you that in which style. I'm sorry guys, this is the coronavirus that we owe to some transparent countries again. And then for the noises. You got it? Let me see, this is recording. Yes. Okay. Now after knowing this, so the command rand a and b generates a matrix of a random rows and b random columns between 0 and 1. For example, so a is equal to rand, means random number of 1, gives you this 0.814, and this number is always between 0 and 1. See, another number, see, another number, see, another number. It continues. It's a random number, generates. Okay, see that? Okay. So a is a random number between 0 and 1. Understand? So now let us generate this together. Practice 5. Generate random row and column vectors as follows. Okay, so a random number that has 1 row and 5 columns. So it's gonna be a is rand 1 and 5. Here we go. See, they are completely random numbers. As 5 columns and 1 row. 5 columns and 1 row. That's right. So I want to have a random number of 10 rows and 1 column. It's gonna be 10 and make this as 1. Here we go. See, 10 rows, 1 column, and they are random numbers. So 2 rows and 1 column. Here we go. That's right. And I did previously 1 and 1. See, 1 and 1. Sorry guys, I have to reduce noise. Okay, understand? So now another operation on the vectors is vector sorting. To sort a vector elements ascending or descending, you want to sort in ascending way or descending ways, we use sort ascend or sort descend commands like this. Suppose your a is, let me delete everything. So a is 1, 4, minus 9, 3.5, 9, 8, 8, 2.34. This is your vector A. That's right. Now try the following vectors. If I say sort, okay, and vector A, and I say ascend, that's right, what you get is this. Starting from the very smallest number, here is -9, then 0.5, 1, 2.3, 3, 4, 4, 7, 8, 9. So it's gonna sorting as ascending. So this is how we sort a given vector, right? We define the vector, sort vector A in ascending manner. That's right. So now if okay guys, so now another example is this. I say your B part 2 is 0, -1, 0, and 1. That's right. This should be. Now if I say sort as descending, I'm gonna have upper arrow. I'm gonna change this to vector B. And now what we have to do, we have to say descend. Okay. Oh, what happened? Oh yeah, it's a typo. It's a descent. Okay, here we go. So starting from the largest number, which is 1, 0, 0, and -1. Going from up to down, that's right. From positive to negative. That's right. So part C, I'm going to say C is equal to -1, as you see here. Look at here, guys. This part 3, C. -1, 4, -5, 6, 2, -9. That's right. And now I say that put sort as ascending. So it's enough that you go up, but you have to change this as vector C. Bingo. From -9, -5, -1, 2, 4, 6 is going up. Now part D, that's right. So part D, you have to change this, that's right. And you have to make it 100, 100, -99, -55, 63, 22, and -8. That's right. Now I ask that you sort as descending. So upper arrow, and here what you're gonna do, only you have to put D, the vector D is descending. That's right. Bingo. From the largest number, positive 100, going to the smallest number, which is minus or negative 99. That's right. And a part E. So I have to type E. E is -3.4, -1E4, writing scientifically I taught you in the first class, 1E3, 4 divided by 1E2, that's right, and 0 and -150. Let me double check. Yes, that's right. And now I'm putting as what? As column, that's right. Here we go. Now if I say at descending, so we have it, only you put E like this. So it gives you from largest number, because, okay, it's a good example, guys. If you see that before your vector or matrix, column or row, or a matrix of n by m dimension, this number appears like as e to the power of 10, this scientific writing, right? 10 to the power of 4, 10 to the power of 6, 10 to the power of 100, 10 to the power of -1, 10 to the power of -10. This means that all the numbers are being multiplied by this number. So as we said, descending, it's going to select the largest one going to smallest one, positive to negative. But all of these are being what? Are being multiplied by this huge number, by 10,000. This means 10,000, that's right. 10,000, this number is 10,000. That means that 10,000 storms multiply by all of these. Understand? So 10,000 multiply by all of these numbers. Okay. Now, number 6. F is equal to root square SQRT of 1E4 divided by 54. That's right. I taught you in the first class. And this is column. That's right. This is another way of writing column. Okay. Hold on. Bear with me. Now this is imaginary number. This is stupid. You cannot leave the imaginary number inside the vector or matrix, because when you go to ME520 or the robotics ME596 or the undergraduate control ME530, we never have such a real system. Okay, so you have to put a magnitude of that. So ABS of 2 plus 100I. Remember, I taught you. This is ABS, magnitude of that. Okay, and this is another complex number. So ABS, this absolute value means magnitude. So 1 minus 56 I. Okay, you're gonna tell me, Pema, why you don't put like this? Because this is number. You have to do this when you are assigning this number to a parameter like a, b, c, d, then you can put this number. It is the same. Okay, and now 3 to the power of minus 3. But as you see, I put here, look at here, transpose sign. So transpose in transpose, so this is column. Transpose of column gives you row. Here we go, as you expect. Understand? Calculating this, putting here, calculating the absolute value, which is root square of 4 plus 10,000. Here we go. The square root of 1 plus 56 to the power of 2. And this is what it is. So your f is this. Okay. Now sorting as descending. So descend. It's enough that you do this. And largest number, 100 point blah blah, 56, 13, and this smallest number. Is it recording? Yes. Okay. So after having this min and max of a given vector, to find minimum and maximum elements of a vector, we use min and max. It's very easy. Okay. So let us do that together. So suppose I'm deleting everything. So a is 1, 4, 5, 6. Now if I say min of means minimum of a, we expect to see, oh, min of a, we expect to see which number here? Guess it? Yes, 1. So because 1 is the minimum of these numbers, right? Now if I say b is 0, minus 1, 0 and 1, okay? And if I say max of b, I'm talking about the part 2 here, guys. Max of the b, which number expect to see? Yes, 1. That's right. Now if I see c is minus 1, 4, minus 5, 6, 2, minus 9. That's right. When I say min of that, min of c, you're gonna see which number? Minus 9. That's right. Or d is 100 minus 99 minus 55, 63, 22, and minus 8. And if I say max of d, I'm gonna see obviously which number? The first element, 100. Here we go. But you're gonna tell me, Payman, are we stupid to do that? Because we are not blind, we can see it. First of all, when you are writing coding, when you go to high-level courses, the numbers are not exactly like this, because everything is based on parameters. You cannot see by your eyes. So you have to, in coding, you have to distinguish which number is the largest, especially for the frequency, for the natural frequency in the vibration course, this kind of things. Okay. Or in the case of section 5 here, look at here. So this is very difficult for you to judge. Okay, when you're dealing with the complex complex, not complex number, I mean that computationally burdened numbers. So a skewer RT of what? 2.2 E2 means multiplied by 10 to the power of 2 divided by 34.5. This means that we have a column, that's right. This semicolumn means we have column. So, and now again, ABS, because it's a complex number, of 2 minus I, means magnitude of that, that's right. And again, ABS of 4.56 minus 4.4I, that's right. And 3 to the power of minus 3 again. But now I make this as what? You see, this is transpose. The transpose of a column gives you a vector. Oh, do you have typo here? Oh yeah, I forgot to do this, guys. Yeah, ABS. Yeah, this is a row. Transpose of a column because of the semicolons. So now I'm gonna say mean of that. The smallest element of the vector E. Here we go. As you expect, and we see the last element. That's right. Now if I go to 6, so F is what? 8.2 E2. Oh, F is 8.2 E2. Okay, divided by 4.5, ABS of 1.1 plus 43.2i, that's right, and ABS of 4.56 plus 4.4 to the power of 2i, that's right. See that we are seeing this is ABS, not NS. Yeah. And 3 to the power of 3.45. And now again, I'm putting transpose. Means transpose of a column gives you a, what is E? This is 3. Okay. So this is, now I'm saying max of that. Max of F, that's right, is which number as you see here? This is the first element. Here we go. It's recording. Yes. Hold on guys. Okay, again guys, I'm uploading all the lectures on the YouTube, okay? Because it's very difficult, these huge videos being uploaded on the Blackboard. It's a very painful process, so I'm customizing for the YouTube, and I can easily access to that even after graduation, and you need Matlab, okay, and for the upper level courses even, okay. So and now vector, if you want to multiply 2 or 3 or n vectors together, so we use star for multiplying vectors with the same dimensions, okay. So now look at the practice 8. So these are the A, B, C, D, okay? And now I'm calculating, first of all, let me go to here. For those of you that you forgot about algebra, okay guys, let me close this. Okay, guys, if a vector A has a dimension of 1 by n, okay, and the B has a dimension of 1 by m, you can multiply A by B, these vectors. I'm talking about the vectors, okay? So then we can generalize the matrix, okay? If and only if n is equal to m, okay? So you cannot multiply A by B vectors if n is not equal to m. That's right. For example, if your A is 1, 2, 3, that's right, and the B, I'm simplifying the concept, 2, 0, 4, that's right. So A multiplied by B gonna be what? 3, 0, and what? And 12. You got it? Look at here, guys. So this is basic algebra from high school. Okay. So if your A is what was the numbers? Let's see it. 1, 2, 3, 2, 0, 4, 2, 0, 4. So 1, 2, 3, 2, 0, 4. So if your A is 1, 2, 3, okay, and your B is 2, 0, 0, 4, okay, so now you can say A is equal to A multiplied by B, okay. First of all, because I'm doing, you see that gives you such an error. Let us read that error. Incorrect dimensions for matrix multiplication. Please check the numbers of columns in the first matches the numbers. Okay, guys, look at here, guys. what you're gonna do, because these are the vectors, I multiplied element by element, so it's gonna be this sign. Okay, gonna be this sign because I multiplied here element by element. Guys, look at here. Oh, what is it? See, I did it element by element. This multiplication element by element. Why I said 3? I'm getting older, guys. This is 2. Okay. Okay. This element by element is you have to write in Matlab with the dot star. Now it gives you the same number, 2, 0, 12. Understand? Now let us say now I'm changing the b as 1 by 4. This is your new b, and again, guys, this is your new b. What the hell is it? Okay, this is your new b, and your a is this. It has 4 columns. This has 3 columns. If I try this, error. If I try this, error, because it says matrix dimensions must agree that you can do that. Understand? So if you have 2 vectors, okay, and if you want to multiply element by element, you have to use dot star, okay, and the same dimension. This is valid for what? This is valid for columns A in m by 1, in B m by 1. Your A multiplied B is achievable if n is equal to m. Then for this example, say your A, I'm saying again 1, 2, 3, it's a column, transpose, and the B is 2, 0, 4, transpose. So A, now you know in Matlab, is 2, 0, 12. Understand? So now if we go to Matlab, let me do that. So clean. So your A, guys, is 1 to 3. Oh, sorry, transpose. Okay, and your B, the old one, yeah, another vector. So you can say C is equal to A element by element multiplication gives you 2, 0, 12, exactly as we are doing here. This is very basic, guys. Multiplying 2 vectors together, multiplying 2 columns together. That's right. Now let us go a little further in Matlab. Okay. Now let's say I want to multiply a vector of this to a column of this. So this is a vector and this is a column. That's right. Again, this multiplication operation is feasible if n is equal to m. If it is not, it's not achievable. Like what? Like A is, guys, 1, 2, 3, and the B is what? 2, 0, and what was 4. That's right. So now A multiplied by B, guys, obviously from mathematics is 2, 2, 0, and 12. That's right, because this is 1 by 3, this is 3 by, oops, sorry, I'm stupid. So it's 3 by 1. So the result gonna be what? 1 by 1. That's right, 1 by 1. But this 3, sorry guys, this 3 with 3 goes to, so it's 1 by 1. So the result gonna be 2 plus 0 plus 12. Result gonna be 14. number. So you see, when I multiply two vectors and two columns, you get the result is a vector, a column. But when I multiply a vector by a column, the result is a scalar. That's right. So if I do that in the Matlab, okay, look at here, I'm deleting, writing. So your A is this vector, and your B, as we did already, is a column. That's right. So if I say C is equal to A only star, okay, in B, result gonna be 14. That's right, because this is 1 by 3, 3 by 1. That's right. So the result gonna be 1 by 1. Now let us see if I use that command that we had previously. Oh, it's gonna give you a matrix, guys. Be very careful. Understand? It's gonna give you a matrix. This element by element gives you a matrix. Why? Look at here. When you say element by element, okay, 2, that's right, 0, let me bring this up here, okay, 2, see, 0, and 4, 4, 0, and 8, 6, 0, and 12. So when you are multiplying the rows by columns based on algebra, if you do element by element, you are generating a matrix. But if you are multiplying two vectors as it is, it gives you a scalar. That's right. So be very careful of this. Now we can look at here, guys. This is very obvious. This A is again this, and your B, okay, your B is this. That's right. Now I'm adding an element. This is a vector of 3 elements. This is column of 4 elements. So what to expect to see by this? Another matrix, that's right. But what to expect to see by this? Not element by element. Yes, error message. Because the dimension, they are not good. One of them had 3 elements, another 4. You cannot multiply a 3 element vector by 4 elements. Understand? But if you put this, gonna generate for you a matrix. So based on that, let me see. Okay, now based on that, please write down this A, B, C, D. I give you 2 or 3. I give you 1 minute. Actually, you can pause it and see. There's no need that I can give you 1 or 2 minutes. Okay. Understand? And now do it at home. Next class I will do that. Now calculate A multiplied by B, A multiplied by C, A multiplied by D, A multiplied by B, transpose C in A. As you see, okay. Okay. So do this. Please do this, and we're gonna see for the element multiplication we need to use this command. Okay. So and then we will talk. We'll discuss this in the next classes. Okay, A, B, C, D, these kind of things. And this is enough for now. What's this? Okay, we're gonna do the next class. This is enough for today.